So the first thing, of course, are Axel's prebiotics. And the first criteria is, of course, that the material is not digested by host digestive enzymes. And typically, if you look at the trials that have been done all through the world, I think you can say gastric acidity, it survives. Host digestive enzymes, they're not really there. And gastrointestinal absorption to a very limited extent. Fermentation by colon microbiota, yes. What we have in the diet, we have our iron-oxylan or oligosaccharides. They come into the colon, get degraded by xylanolytic enzymes, be it xylenases to transform iron-oxylan into Axels. And then these materials, be it the oligosaccharides as such or the monosaccharides, are being taken up by the bacteria going through the fermentation process, producing short-chain fatty acids.
We've become particularly interested in one, and that's peptide YY, or PYY, and I think I'm going to talk about it, but really we think of it as a marker and a proxy for hormonal changes within the bird, and we think we're bringing those about by using an enzyme. And peptide YY is produced in the L cells of the gut, and these cells are expressed all the way through, but particularly towards the end. And we think it acts to delay gastric emptying. The reason it sort of chimed with us and became interesting is because it's most induced by digestible fibre, but also fat. So we see in the literature, when short-chain fatty acids are infused directly into the colon, and there's various papers, particularly with rats, to show PYY secretion dramatically increases. So we're hypothesizing, could the products of xylanase act as a prebiotic? We think they probably do. Enhance fermentation in a beneficial way, and hence PYY secretion, which then knocks on to animal performance.
There are so-called saccharolytic bacteria that can ferment carbohydrates, and they are producing various short-chain fatty acids, lowering pH. And then this lowered pH has certain effects. For example, it affects some mineral uptakes, and also it inhibits some pathogenic bacteria, or that kind of claims being presented. Also, these acids directly affect the pathogens, for example. We took samples from different commercial farms in Finland, and then we clustered them so that those with good FCR, they are shown in these graphs. And those with moderate FCR, you can see quite significant changes in the microbiota. They look quite different.
So altogether, is that promoting digestibility and promoting performance? And I think it's important to say here, because we're talking about xylanases ultimately, this is potentially giving us a whole diet effect. So we might not just be gaining back energy, because we're influencing digestibility of the whole diet. So could we be improving amino acids, improving fat? We know a lot about fat digestibility with xylanases. We've talked a bit about that. So it's potentially a whole diet effect that we're seeing.
If the xylanase is actually working on holding things back via the PYY mechanism in the gizzard, that's where your phytase is working. If you give that phytase a little bit longer time to work, then it's got more chances of reducing phytate levels further and improving inositol levels or increasing inositol levels further as well.